1 minus x times dy dx equals 5 minus 2y. It's not in standard form, is it, to do the integrating factor method, so let's just rearrange things. The first thing to do is move the minus 2y over to the left-hand side. So 1 minus x stays where it is with the dy dx. Then minus 2y moves across the equals to become plus 2y equals 5. Leave the 5 where it is. Now we're still not in standard form. Let's divide by 1 minus x all the way through then. Gives, so divide this by that, you just get dy dx, plus 2 over the 1 minus x then, times y, is equal to 5 over 1 minus x. Now it is in standard form, we can circle the p, so let's do that now. So here it is here, and that's p. So now we can work out the integrating factor then from this problem. So here, the integrating factor is equal to e to the integral p 2 over 1 minus x dx. There it is there, which is equal to 2 lots of 1 over 1 minus x integrates to the log of 1 minus x, doesn't it? With a minus, because it's a function of a function. Let's just check it then, differentiate this in our mind's eye. Log of something goes to 1 over something, which is what we've got here, multiplied by the 2, multiplied by the something differentiated, which is minus 1, and that'll make that a plus with the 2. Yeah, so that's fine. So now we need to move the 2 out of the way, so that will equal ln 1 minus x, and the minus 2 properties of logs comes up to be the power there, doesn't it? So now we've got e log right adjacent to one another, so they'll cancel each other out to leave 1 minus x to the minus 2, and that's the same as 1 over the 1 minus x squared, isn't it, if we want to write it like that. So let's multiply through by this then. So let's multiply through by our integrating factor, and we'll have 1 over 1 minus x squared dy dx. Then it's plus 2 lots of y over, there's already a 1 minus x there, there's 2 more here, so we'll end up with a 1 minus x cubed, isn't it? Cubed is equal to 5 over, and again there's 1 minus x already there, so that will make a 1 minus x cubed. Okay, so that's what we've got there. So now we can deal with this problem now. All we simply do is circle the u and the v, and the u is here, same every time, and the v is there. So here we have d by dx of u times v, here's u, as we said, times the v, which is y, will equal the 5 over 1 minus x cubed, which you can write as 5 1 minus x to the minus 3 if you wish. Integrating both sides now. See what we get. The integral of this, the integral of the derivative is just a term inside the bracket, 1 over 1 minus x squared times y is equal to the integral here of this, 5 lots of 1 minus x to the minus 3 dx. Now we just need to do that integral. It's a simple little function of a function, isn't it? So here we get equal to 5. Now this is going to raise that power by 1 minus x to the minus 2. When you differentiate this, the minus 2 will come down here, so we'll need a minus 2 there to the minus 3. But then a minus will come out to be with that minus. But the minus 2 comes out, it's already there, so I need a plus, don't I? Yeah? So let's just double check that now to this, make sure that this stuff here differentiates to this. So the power, minus 2 comes here, to cancel with that 2, and we'll have minus 5, that to the minus 3, multiplied by the something differentiated, and that differentiates to minus 1, to go with the minus that's here in our mind's eye to make the plus, so that's fine, plus a k at the end. So we've got y over 1 minus x bracket squared is equal to that. So I'm going to multiply through now all the way through by 1 minus x bracket squared. Here we'll get a y. And by the same token, we'll just have 5 over 2 here, plus k times 1 minus x bracket times and by. So that would be squared, won't it? Okay, put the initial conditions in then. At x equals 0 for this question, we're told that y equals 1. So we've got that. So let's have a look at that problem then. 1 in here, 5 over 2 there, plus k. X is 0, so put 0 in here, we just get 1 squared. So that tells us then that k is equal to 1. Move that 5 over 2 across to minus 5 over 2. So the answer is minus 3 over 2. So finally then, we have y is equal to 5 over 2 minus the 3 over 2 is the k value, times 1 minus x bracket squared. There we go. There's our solution.